try to do this one. Well, let's try this. Do I find a safe tile because the droid is stronger than me? I try to run away. But if this part fails, I go back up. It's a selector. It's an OR. Okay. Well, there's no choice. I have to attack the droid because there is a droid in range. That's the behavior that you're putting together in this tree without explicitly spelling out those if statements and transitions between all the different routines. It's a completely different way to organize your states and behaviors and transitions. Does that make sense? So this is a behavior tree, and this tutorial shows you some examples of the code, how you would put that together. Is there a droid in range, etc. Has the act, and then it has this succeed and fail and is running. And then the question we need to ask is, do we do this every single time step? To really implement these well, you need to keep track of sort of where you are, what is currently running, what is trying to execute, and then when the update loop comes back around, you pick up that node. So you've got to have a good traversal. You've got to have a good iterator going on through your tree to help you on the back end evaluate what should be going on. And then every time step you try to execute some more. You might actually execute according to action points is what they recommend. So your tree has 5 actions that it can try. So it tries to evaluate this, tries to evaluate that, 3, 4, 5. Okay, then it goes to sleep, lets the graphics update, wakes back up. Says, oh, I was here, I was trying to evaluate something, I'm running. Okay, is this working? No, 3, 4, 5. Oh, okay, goes to sleep, wakes back up. Make sure the behavior tree isn't taking 1,000 updates in order to figure out what goes on. And your game lags. You got to make sure that part is efficient as well. Theoretical stuff can work. There has to be implementation details to make it work as well. Because people say, I want to make a behavior tree, and they make behavior trees like this. Where did it go? Just view the image. Here we go. Once you have that logic together and your selectors and your repetition and your ands, ors, and other connectors, you can start specifying huge amounts of behavior, and you've got to be able to wander through this efficiently. It's got to be more than just a tree you're exploring, but a back-end interaction, making sure you know where you are, organizing it on an efficient scale. Does that make sense? Okay, so again, like the state machines, Unity has some tools that you can download and use to help you. Where is my search button? Is it gone because it's so small? Yes, my screen is so small. Okay, so this one has really good ratings. Behavior Designer, it's 70 bucks. It's expensive, but it lets you in Unity graphically put things together. There's tons of code that comes with it. When you buy this, you are buying all these C# files and the way that it puts stuff together. But it also has this graphical way of letting you program with selectors, sequences, putting together your behaviors graphically. So these are the kind of things that a developer like you can do, knowing more about programming than a game designer. In an actual setting, you would be probably working with a designer, making something happen, saying, there's a general way to do this, making a tool, distributing it so that somebody else can come along and drag and drop and put things together. You're going to be involved in the game design, but in industry, developers are more tool creators than they are game designers. It's a different piece. Indie games, you're doing everything yourself, doing whatever you can just to make it work. In a large setting, you're a piece of a team, and this is how that team sort of fits together. I always try to make sure I relate that back because people have wild expectations of what they'll do as a game designer in industry, and you are going to be doing different things than you expect. And that's okay, just as long as you recognize where the pieces are and how you can fit it together, and talk about that with whoever you want to work with. What will I be doing on a day-to-day basis in the industry? Okay, etc. All these different trees you can create, all these different ways you can put them together, selectors, sequences, inverters. If this one failed, then that means it really succeeded. Internal nodes can be put together in whatever way you want. Okay, so questions about behavior trees. If you wanted to implement them, that would be really, really cool. I'm not going to make an assignment where you implement behavior trees, but I wanted you to know there's more than just a finite state machine out there to manage your behaviors, to make your AI characters have that type of intelligence. And people have spent time thinking about it, implementing it. It's achievable by you with that kind of stuff that's on this tutorial. There's a lot of great starter code to get you going if you want to put that into your games eventually. But there's a lot of things to think about. There's a reason they probably charge $70 because they can, and people will pay that for incorporating smart implementations of a behavior tree into their code. Okay, so that's where we are. You are still working together to put your games implemented. Is anybody finished with them? I didn't think so. I didn't expect anybody to. So that means we have a great opportunity for an hour of work. Let's make things happen with your game. That's our plan. Awesome. Well, I completely forgot to open up the chat stream. Obviously, I can't figure out what happened now, but if you've been chatting, thank you, and I will talk to you later.